Good morning, students. So today we are going to discuss regarding the methods and the factors controlling the directional solidifications. Okay, in the previous class also we have discussed regarding the proper designing and the positions of the gates and the risers, use of an insulating pads sleeves for the risers, use of an chills in the mold. Also we have discussed in the previous class regarding the internal and the external chills placed inside the mold cavity. Now use of the blind binders also discussed. Okay, the last concept which was left in the previous class, that is an exothermic rise components. So see, this exothermic rise components are the loose material essentially mixed with the metal oxides. Okay, magnesium, cobalts, nickels, okay, etc. These are the loose materials. The aluminum sprinkled on the top of the riser in the place of an insulation powder, either the function is to prevent the heat losses from the top of the risers and also add some heat to the mold materials in the risers, thereby allowing the metals to stay hotter and necessary for achieving the directional solidification. So see, this exothermic components are such components that which release the heat. Okay, sorry, not release, it absorbs the heat. Okay, so these types of exothermic powders or the materials are being used for solidification methods. Over here the main function is to prevent the heat losses, okay, from the top of the riser and also add some heat to the molten metal. Okay, so this is one of the exothermic reaction which has been used for the this is one of the exothermic reaction occurs over here for stopping the heat. Sorry, so this is what exothermic reaction just now I have told. Okay, it is a reverse, that exothermic reactions are used for releasing the heats. Okay, these are been used like an insulator which sprinkled on the riser so that the heat cannot be uh, heat has been released by this exothermic reaction and the heat is maintained within the riser so that the molten metals doesn't solidified before the molten metal which is solidifying in the cavity. So this is how the solidification that which helps in the directional solidifications. Okay, this is also one of the important method and the component. Now let us say the degasification in the liquid metals. Has known, the gas are much more soluble in the liquid, that is in the solid metal. So gas are much more solid. So see, when you are what do you mean by the degasification and why it is required, I will tell you before going to the degasification method. So see over here, when you melt the metal, in a furnace, at that moment what is happening during the melting process is carried out, whatever the gas are there in the atmosphere has been trapped within the molten metal. Okay, that if you don't remove that gas from that molten metal, what will happen, the gas remains in the molten metal during the solidification. Okay, process, the gas is been trapped within that solid materials and that casting may undergo certain defects is, okay, that defects is may called as in porosity holes, that gas holes are being generated which may further become some casting defects which may called as in blowholes, pinholes, etc. Okay, these types of defects are being generated when the gas is being dissolved in the molten metal. For that reason we have to remove the gas from that molten metal before pouring it into a mold cavity. So which are the methods and the sources are being used and what are the preventions to be taken for the degasification, that we have to study now. Okay, gas absorbs in the molten metal from the various sources are listed below. So how does the gas enters in the molten metals? Okay, furnace atmosphere, furnace charge and the ladle. So what do you mean by the furnace atmosphere? The atmosphere inside the furnace where the melting is been carried out, the surrounding of that furnace is full of carbon dioxide, sulfur dioxide and carbon monoxide. Why these gases are generated near the furnace? Okay, and these gases are surrounded to by the furnaces, because when the fuel is being used for the burning of an furnaces, okay, if you take the wood or the charcoal, by means if it is a couple of furnace, at that in such a furnace circumstances, the gases which are released by the fuel which is used for burning the furnace releases the harmful gases which are the carbon dioxide, sulfur dioxide. These gases revolves around the furnaces, and these gases may be entrapped or been dissolved in the molten furnaces. Okay, so this is one of the important source of the gas to enter in the liquid furnace. Maintaining the cleaning and the dry atmosphere inside the furnace, and the furnace wall keeps to be reducing gas absorptions. Okay, so how the prevention is being taken? the the amount of the gas absorption depends on the condition and the types of the melting furnace. Okay, just now I've told, if there is an induction furnace, the gas doesn't uh, released by the fuel. Okay, only whatever the atmospheric gas is there, that can be only absorbed. If you use the cupola furnace, so the charcoal or the wood is being used for the burning of the furnace, so which releases after burning the wood and the charcoals, it releases some gases, that's carbon dioxide, sulfur dioxide. Okay, that gases are being entrapped or dissolved into the molten furnace. For that, the prevention is that the cleaning and dry atmosphere is there, should be there. Okay, see that the gases should not enter the molten metal. Okay, the liquid where it is been melted, metal is been melted in the liquid, that should be closed over there. Now next is an furnace charge. What do you mean by the furnace charge? The furnace charge is nothing but the, you are charging the furnace by any of the raw material, wet, oily materials or the contaminated scrap charged into the furnace. Okay, to contribute to a gas absorption. So see, whatever the charge you are putting, charge means what, whatever the metal you are going to melt in the furnaces, that has to be cleaned before when you add to the furnace. Okay, if any cast iron or the mild steel, if you are going to melt over there, that should be cleaned before putting into the furnace. Okay, before it melt. Okay, whatever the contaminants or the dust particles are been added to that scrap or the raw material, that should be cleaned. If you are not cleaning directly, if you are putting into the furnace, what happens, the some of the harmful gases, okay, when it comes to an contact with of an any chemical reaction may occurs. Due to that, some of the harmful gases are been releasing out, due to which that gases are obviously entrapped or closed within that molten metal, due to which the gas are been trapped into that molten metal or residuals into that molten metal. So that should not happen. If that thing happens when the casting gets solidified, it may undergoes for the casting defects. So these things you have to keep in your mind, and what is the prevention should be taken. So whatever the charge or the material you are going to be made, that should be cleaned before it is added to the furnace for the melting purposes. Okay, use the dry and clean charge and help in reducing the gas absorptions. Okay, so this is what the prevention has to be taken for the when you charge the furnaces. Now third is on ladles. So see, the ladle is, what do you mean by the ladle? The ladle is nothing but it is an crucible cup or the carrying instrument from where the furnace is melting the metal. From there the molten metal or the melt metal you are carrying and pouring to the in a mold cavity. Okay, so the carrying movement is there, but it is been done, the molten metal is done by this ladle. Okay, this ladle should also be cleaned and dried on. Okay, if it is not clean and the dry one, whatever the contaminates when it comes to the open atmospheric conditions, okay, some harmful gases or the dust particles are being deposited on the upper surface of that ladle. if you doesn't clean or dry it, so what happens that if you pour the molten metal in this ladle, so the chemical reaction occurs, whatever the dust particles are there, they start to release some harmful gases. That gases are been trapped within the molten metal or enclosed in the molten metal, so that causes the casting defects, okay, blowholes, porosity holes. So for that reason the prevention should be taken that the ladle before using it should be clean and it should be dry. Okay, how to dry? You can sprinkle the water on that one or any of the chemicals, you can sprinkle it so that the all the dust particles on the ladle should be removed out. Okay, so this is what the source of the gas generated in the liquid metal and the basic prevention that you have to take when you use the ladle. Okay, now we'll go for the next one, the furnace to the ladle. Furnace to the ladle or ladle to the mold. So what do you mean by the furnace to the ladle or ladle to the mold? From the furnace to the ladle, okay, when you tilt the furnace, when you are going to pour the molten metal into the ladle during at near the furnace, okay, at that moment what is happening, the liquid metal which has been dropping out or which has been sent into the ladle directly come to the atmosphere contacts. At that moment whatever the surrounded gases are there in the furnace surrounded gases are there, okay, that have been going to trapped. Okay, when it are going to trap from the furnace to the ladle, when you are going to tilt the furnace or pouring the liquid metal on into the ladle. Okay, then from the ladle to mold, then once again you are lifting the ladle and going towards the mold, okay, where the mold cavity is there, where you are going to pour the molten metal. Between this distance furnace to mold, the ladle which is handled by any of the operator or the person worker who is carrying out that ladle with the filling of a molten metal, he is directly, that ladle is directly coming to the contact with the atmosphere, where it also enclose the gases from the atmosphere. Okay, or the where the workshop is there, where the furnace, where the foundry shop is there, from there surrounding whatever the gases are there, that has been entrapped in that one. Okay, that is to be thing, keep in your mind. Okay, now how these are the source, how the gases are entrapped in the molten metal. Now what are the preventions to be taken? The pouring temperature as low as practical possible, maintaining the metal handling conditions, okay, like skimming, stirring and re-landing helps in reducing the gas absorption. Skimming, stirring and rending. When you carry the molten metal from the furnace to the mold box, at that movement you have to continuously stir the molten metal so that the whatever the gases are there, that may comes on the upper surface of the molten metal and exposed to the atmosphere. Okay, so this are the prevention should be taken during the carrying the molten metal, okay, in the mold. When you pour the molten metal in the mold, how the gases are being entrapped. So see, whatever the sand mold cavity which you have prepared for pouring the molten metal inside that one, that mold sand mold cavity is made of the mixtures of the moistures and different types of clays. Okay, when the moisture is added, that means what, water is added in the sand, when you put a hot molten metal, that moisture starts to release the gases. Okay, that gases are being entrapped within the molten metal which is inside the box within that cavity. Okay, so for that reason what is to be done before prevention, okay, so what has to be done when the mold cavity is been done before pouring the molten metal, that mold cavity is been preheated. One fire flame is been introduced within that mold cavity by the means of, by the way of runner or the riser, you have to introduce the fire flame which hits the mold cavity and released all the moisture particles from the mold cavity, so that the percentage of the gas releasing by that moisture is been reduced over there. Okay, so this are the some of the preventions and the sources of the gas generated in the mold cavity. Now next we'll go for the degasification methods. The following are the different methods of degasification. First one is on flushing, second is on vacuum degassing. Okay, in that static bath treatment is there, induction degassing is there, stream droplet degassing is there, and the fractional degassing is there. So what is the degassing method? So just now you have studied, you have discussed about the sources, how the gas is been entrapped or mixed in the molten metal, and what are the prevention to be taken if the gas should not mixed. Now the degasification method is nothing but if the gas is mixed, now how to remove that gas from that molten metal, that we are going to study. So there are some methods are being used for that one. Okay, now first one is an flushing. The flushing is an inert gas or degassing conveying. So see, flushing is an degassing method in which the inert gas is being used, like such as chlorine, nitrogen, helium, and argons are being used in participants for degassing the non-ferrous metals, while carbon monoxide is being used for the ferrous metal. Now let us see the diagram how the degasification is being done. Now you see in this diagram over here there is a crucible cup is there. In that crucible cup the molten metal is there, there is a liquid metal is there. Okay, and over here there is a graphite tube is there or the pipe is there. Okay, so now what they do go for the degasification in this tube with the help of the storage cylinder of different gases. Okay, that's are called as an inert gases. Okay, such as argon, nitrogen for the non-ferrous, and the carbon dioxide for the ferrous material. If the material is an ferrous, carbon dioxide is been released. If the material is a non-ferrous, then the arrogance and the nitrogen gas has been released. Okay, so these gases are been passed through this graphite tube. Okay, why the graphite tube is used? Because it is having a high melting point than the another metals. Okay, so this graphite tubes, the gas is been released into the liquid molten metal within the crucible cup. Now you can see how the gas enters. It starts to comes to the upper surface of the molten metal. When the gas comes to the upper surface of the molten metal, it itself carry the another gases and allow the other gases to move with them from the bottom to top at the upper surface of the crucible cup. Okay, as the crucible cup is a non-vacuum, so it is open to the atmosphere. So whatever the gases which are coming from this liquid metal, okay, or the molten metal, the gases are being released at the upper side. Okay, this is how the degasification is done by the flushing. Now in the vacuum degasification there are two types. One is a vacuum degasification and the static gasification. By the help of the diagram I will explain you how the degasification method is being done in the vacuum. So see the diagram number 1. Here is a diagram number 1 A and diagram number B. So the both are the process are different, but are the vacuum one, and this is a static bath degasification, and this is also an static bath degasification, but the procedure are been same. Why it is called as a static? Because the crucible cup is been stable over here, no movement of the crucible is done or no changes has been done. Okay, now you can see over here there is a vacuum cylinder is there, chamber is there, in which the cup with the molten metal has been placed. Okay, then this chamber is been closed or sealed down. Okay, to then afterwards what is happening, it has been allowed for 2 or 3 or 4 hours or 2 or 3 minutes or 6 minutes as per the melting points. Okay, the within that chamber the vacuum is generated, the high pressure is generated, this pressure is been within the vacuum is applied on the surface of the molten metal. Okay, and allows the gases to compress over there. Hence the gas have been compressed, the gas density has been reduced, and the gas comes at the upper side of the surfaces and comes within this chamber. Then afterwards what is been done, this chamber is been opened out, the upper case has been opened out, and the gases are been released to the atmosphere. In same procedure is also done in the Diagram number B. In the ladle, the molten metal is been pressed. Okay, the ladle is been sealed down and the high pressure is been applied on the liquid so that the gases may released out, comes out from the liquid metal. Okay, now let us see the induction degasification. So see, induction degasification, you can see in this diagram, it is also done in the same vacuum chamber is over here, but over here the difference is that, so whatever the molten metal is been placed in this crucible cup is been surrounded by the induction coil. Due to this induction coil, the power is been supplied to that coil, due to which the eddy current is being generated or the magnetic force is generated, with which generate a stirring action within the liquid metal or the molten metal. Due to this stirring action, what happens, the gases which are being entrapped in this molten metals are being starts to release out, starts to released out from that molten metals and exposed to the exposed within the chamber, are been related within the chamber. This process has been done for few minutes as the maximum gas has been released out, and then finally it is been used for the pouring purpose. So this is how the induction degasification is been carried out. Okay, now next we'll go with an stream droplet degasification. Now see, in this stream droplet gasification, you can see over here at the top there is an bottom pour ladle is there, or the crucible is done, and this is also one of the rapid degasification method. Okay, fast degasification method is there, and over here there is a vacuum chamber is there. Within this vacuum chamber an empty ladle is been kept or the crucible is kept. Okay, now this filled ladle is been placed over here. At the bottom there is a plug is given, or the opening hole is there. It hole is been open out. From this hole the liquid metals enters to the vacuum chamber, but the liquid metals comes out from this ladle into a small droplet. On a small drops of the liquid metals are been falling within the chamber and is been collected by this bottom ladle. Okay, that droplets of the molten metals are been collected in the bottom ladle. Okay, within this gap whatever the gases are been entrapped in this molten metals are been released out during the distance it travels from the top ladle to the bottom ladle. Okay, in the droplets manner, the whatever the gases are there that are been released out within this distance and collected into this vacuum chamber, then with the help of the pump that gases are been sucked out and throw it into the atmosphere. Now next degasification method, you can see the fractional degasification. Now you can see over here there are the molten metals are there. Over here there are the two tubes are there, and this is a vacuum chamber. Okay, and this is outlet where the pump of the vacuum is being done, and over here you can see the argon gas is being supplied, and this is what the ladle is there in which the molten metal is being kept. So before going to this, if you have seen the experiment, if there is a bucket full of water, okay, then when you placed on the water bottle in that one, what you can see, otherwise the Bisleri tanks are there in where the tap is given. At the top there is a huge tank is there, at the bottom there is a small tank is there, for that tap is there. When you open the tap for the drinking the water, you can see the air bubbles are coming at the top of the tanks. Okay, that's phenomena is been applied over here in the fractional degasification. The ladle is there in which the liquid metal is been already poured. Okay, you can see over here the ladle. From the one tube to the of the vacuum chamber, the gas is been supplied. As the gas is been supplied, the pressure is been generated. With this pressure the liquid enters in the vacuum chamber. Okay, when it gets enters in the vacuum chamber, the whatever the gas is there, it comes at the upper side of the surface of the molten metals and collected in this chamber. With the help of the pump, that gas has been removed out. So this is how the fractional degasification method is been worked. Okay, now let us go in the next concept, that is an fettling and cleaning of the casting. What do you mean by the fettling and cleaning? The fettling and the cleaning is carried a cut following shakedown or removing of the casting from the sand mold and knockout, removing of the sand core from the casting operation. The fettling includes the following steps: removing of sand and other impurities, removal of an excess metal, finishing of the casting. So see, when you pour the, when the casting is been removed, okay, when the casting is been removed, at that moment what is happen, from when you remove the casting from the box, so how the shape of the casting is there. So see, whatever the liquid is collected in the runner, riser, gates connected to the casting, okay, are been solidified at a time. Just so far you have discussed, okay, are been solidified. When you remove that total assembly, solidified assembly, okay, of the runner, riser and gates which are connected to each other, when they are solidified, when you remove that outside from that molding box, they are connected to each other when they get solidified. In the fittling shop, what they do, they cuts the gates, runner, risers which are attached to the casting, okay, that cutting is been done, and whatever the rough surfaces occurs on the casting body, okay, that has been grinded, or the burrs which are comes on the surface which are been grinded by the grinder or the hand tools grinder, okay, by the operator, and make it smooth. Then in the next, whatever the sand which is attached to that casting is been cleaned out by the short blasting processes. What do you mean by the short blasting? The short blasting is nothing but on a machine in which the casting jobs or the workpiece are been kept over there, and a small metal balls or in sand is been with a high pressure sprinkled on the casting. Due to the abrasive action between the sand and the balls or the heavy siewless sands, okay, the sand which is attached on the casting is been removed out or fall down, okay. At the same time, this short blasting is carried in an high temperature oven, okay, where the temperature oven is there, the heat is been released. Due to the high temperature heat, the wet sand which is attached to the casting is converted into a dry one, and it removes out the sand or the which is attached on the body of the casting. So this is how the fittling shop is been done, okay. Now the removal of the sands and the other impurities, I just now told you, either chemical cleaning methods utilize the bath, okay, or the chemically it can be used, okay. Some chemicals are being used for removing the sand, which are the chemicals, that in caustic soda containing the additional agents, okay. Caustic soda is being used for removing the sand. The total casting is been dipped into a caustic soda liquid, okay, and it has been washed out, okay. Like this way, the sands and other impurities are been removed out. Now you can see the air blasting. Just now I've told the short blasting, that is an air blasting, hydro blasting, tumbling are been done for removing the sand from the which is attached to the casting. Now next is the removal of an excess metal. So just now I have told what is the excess metal. These steps includes removing the excess metal such as the fins, which are the rough portion occurs on the mold, okay. Blaster stumps of the gates, the gates and the risers which are attached to that one, which are the unwanted projection of the casting, that has been cut out. This is achieved by chipping, the sawing, flame cutting, okay, by the grindings and other operations. Now finishing of the casting, finishing is carried out to the smooth part of the casting where the gates and the risers are attached, okay, and also improve the surface finish, and the appearance of the casting. The different finishing operation like grinding, polishing, buffing are being used for these purposes, okay. So this is what the finishing of the casting is been done. Now next we will go for the casting defects. So these are the important one. casting defects for the exam point of view. So the casting process involves a number of variables and the loss of control in any of these variables. Okay, there are so many variables are there, you have to take into understand during the solidification variables, casting variables, pouring variables. So far we have discussed in the classes. Okay, due to the lagging within these variables, so you may go undergoes, the casting may undergoes for the different types of defects. Okay, now the shrinkage defects, first one is in shrinkage defects. So everybody knows how the shrinkage defect occurs. The shrinkage defect is nothing but the shrink occurs in the mold metal during the solidification, okay, or after the solidification the shrink occurs during the mold metals. It contracts or reduced its volume within the mold cavity. That is called as a shrinkage defect. Okay, the shrinkage is avoided on the surface of the casting resulting from contracting or shrinkage of a metal during solidification. Although the rise is used to overcome the shrinkage effect, in some cases it fails to feed the molten metal sufficiently to an casting as it solidifying. So what is the prevention to be taken for the shrinkage effects? Okay, use a larger spheres of an riser to promote the directional solidification. In the previous class I have explained how does the riser help in the directional solidification. The riser works like an reservoir. Reservoir means what? The liquid metal which is collected in the riser during the solidification of the casting in the mold cavity, or the metal during the solidification of that metal in the mold cavity, it starts to reduce its volume or start to shrinkage. Okay, when it start to shrinkage, it requires more materials to adopt its uh, shape or to get a desired shape. That extra material is being supplied by the risers continuously. Okay, so this is one of the remedy, that the risers design should be done properly so that the directional solidification can occur, then you can avoid the shrinkage defects. Locate the risers and gate system in correct position. In correct position the riser should be there so that the continuous liquid molten metal can be supplied to the mold cavity during the shrinkage. Okay, and one more important thing is that you should keep the shrinkage allowances within the pattern so that the extra amount of the mold cavity can enters within the mold, extra amount of the molten metals can enter in the mold cavity. Now porosity defects, blowholes or the pinholes. So see, the molten metal absorb the gases. When just now we have discussed, when it absorbs the gases, okay, the molten metal, when you pour that gas closed molten metal which is having the gas inside the molten metal, if you pour in the mold cavity, it undergoes for the solidification. After solidification what happens? Okay, the casting is being removed out, there will be a small holes you can see on the casting, because during the solidification the gas starts to come out and produce some small holes or the blowholes on the surface of the casting or within the casting. These types of defects are called as blowholes and the pinholes. So what are the remedies for that one? Avoid an excess ramming of the mold. So whatever the ramming you are doing for the mold, okay, you should not do an excess extra ramming, do lightly ramming. Provide a proper vent hole. So see, whatever the mold box is there, over there at the top there should be a small holes are midden from, because of that holes, so whatever the gases are released from the molding box, okay, from the mold cavity or from the molten metals, can come out by that vent holes. Okay, so this is one of the important remedies that you have to keep in your mind during to avoid the porosity defects. Now misran. Now what do you mean by the misran? Misran occurs in the mold cavity. See, you can see in this diagram, this is the mold cavity and this is the sphere from where the molten metal is been coming out. When you pour the molten metal, it fills the mold cavity and it has been stopped over here. Okay, why? Because the if the pouring temperature is less, okay, it starts to solidify. Before reaching to this, it starts to solidified over there. Okay, so this type of defects are called as a misran. Misran occurs when the mold cavity is not completely filled with the molten metal. In other words, it defects wherein the casting gets solidified before the molten metal completely filled in the cavity. Before filling the complete cavity, the molten metal starts to solidified and stopped over here, it doesn't move further. These types of defects are called as a misran defects. Now next is an penetration. What do you mean by the penetration? So see, when you pour the molten metal into the mold cavity, okay, that mold cavity should not penetrate within the mold. Okay, so whatever the mold you have prepared of the sand, okay, that molten metal, liquid metal which you are pouring in that one, that should not enters within that sand. Okay, if it enters within the sand, so whatever the molten metals is penetrated means what, enters within that sand wall, mold cavity wall. Okay, that starts to solidified over there. Okay, that start to solidified over there. When you remove the casting from that mold cavity, it doesn't appears very good in look, or some of the zigzag appearance may occurs on that casting surface. For that reason, what as the remedies you have to follow, the sand should be properly rammed. Okay, it should be hard when you rammed it. The mold sand and the coarse sand should not be coarse to promote the metal penetration. Should not be coarse to promote. The sand should be in such a way that it should not penetrate the molten metal or promote the molten metal to enter over there. Coarse sort, it should be plain. The mold cavity walls should be plain. It should not be rough. Okay, if it is in rough, so the molten metal may enters within the mold walls. The mold shift, it is a step produced in the casting product along the parting line. So see, this is what the parting line is there. This is a cope and this one is an drag. When you pour during the pouring the molten metal or after pouring the molten metal, if the parting line shifted, both the box are being shifted by each other, the casting during the solidification, okay, the casting doesn't comes in a proper parameters or the dimension. The alignment of the casting is being changed. Okay, what will be the remedies? The proper alignment of the cope and drag is to be done. Proper handling of the assembly of an cope and drag during the operation. Okay, it happens only when during the operation pouring time, it may be by the operator or any of the person by circumstances, if the box has been shifted from its parting line, so these types of mold shape defects may occur. Now next one is in cold shuts. The two positions of the metal flow together, but lack of fusion due to the permeable freezing results in the defect is known as an cold shuts. Now hot tears. The hot tear is an internal and external drag discontinuity of the casting due to a pulling action of the metal. Just it solidifies. So see, this is the diagram shows the cold shuts over here. So see, the remaining sides of the casting is been solidified, but some of the inner part is not solidified over here. It remains in the liquid. Just you have seen if you have boiled the egg, okay, if the complete egg is been boiled completely, so whatever the inside you can see the yellow part is there, that will also be a solid. If the egg is not boiled properly, so what will happen, the yellow part within the inside the egg, okay, the white part will be in a solid one and the yellow part will still remains in the liquid. So such type of situation is called as a cold shut. Okay, same thing happens in the uh, casting also. The all the casting parts are been solid, okay, and the center part is been in a liquid form. This type of defect is called as a cold shut. And the hot tears are nothing but the edges of an casting are been not properly come out while the solidification. There are some marks or the chamfer is been occurs on the internal or the external continue of the casting. Okay, these types of defects are called as an hot test. Now what are the remedies for these types of defects? Provides an adequate fillets at a sharper corner while designing the components. Proper metrological and the pouring temperature to be maintained. Place a gates and the risers at the suitable location. So these are some of the remedies that has to be keep in your mind, okay, to avoid such types of casting defects. Now let us see the advantage and the limitations of the casting process. What are the advantage? A larger hollow and intact shape can be easily cast. Okay, any of the complex material can be removed out by the casting. Okay, complex design can be removed out by the casting to have the complex component. Quick process, it is a faster one and hence suitable for the mass production. Okay, nowadays maximum production is been done by the casting. No limited to the size and shape, any size and shape of the casting you can do, only the required capacity of the furnace is required. Okay, the parting range of in few millimeters to meters, a few grams to tons can be cost efficiently and economically from small to foots. Okay, the size of the casting of the box. Okay, from 1 kg to 2 or 3 tons metals you can easily melt. Okay, and this process can be done. Better dimension tolerance and the surface finish can be obtained by good casting. Okay, so casting exhibit a uniform properties like directional, longitudinal, lateral and a diagonal. Okay, every properties can be adopted in the casting exhibits. Okay, uniform property, either it longitudinal in a straight line, in a vertical line or in an incline, that is a diagonal. Now what are the limitations of the casting process? The first one, the presence of the defects in the casting parts is a major disadvantage. Okay, so the defects are not easily identified in the casting, and for removing the casting defects is a major disadvantage of the casting process. If the casting undergoes for the defects, it may cost heavier. Okay, the casting process is not economical for small numbers of parts. Okay, if for the small production, for one or two numbers of the production, the casting is not economical. It may be costlier, it is costlier. Okay, now third one, the property of the casting materials are generally interfere when the compared to those made by the machining or the forging process. So see, the forging and the machining processes are being done for manufacturing or producing a new products. Okay, if you compare their properties with the casting, there is a slighter differ, because in the forging there is no molecular change, in the machine there is no molecular change is been done, but in the casting the molecules are completely dissolved and generate a new molecules, and the microstructure is generated in a new format. When it generates in the new format, obviously the property of that particular material will be changed. Okay, so these are the some of the advantage and the disadvantage of the casting processes. In the next class we will go with the introduction of a non-ferrous foundry practices and the processes of the non-ferrous foundry practices. So far the casting process are completed with the defects. Okay, degasification method, fettling and casting method. Okay, now the degasification methods are completed and the degasification in the liquid metals are be completed. So today's class we will going to wind up over here. Let us continue with the next class.